So today we are covering the last topic. In fact, it's kind of bittersweet. It's going to be the last triangle specific lesson that we have, ever again. They may creep their way in later, just as kind of a, sneak peek, or hey, there's a triangle inside this other shape. Let's throw back to those days. But this is the last new set of information involving triangles that we're going to have. I say bittersweet because we covered 3 whole units, each one adding extra layers and features to what we can do with triangles. Now, I would argue in the real world, triangles are probably the most powerful shape that you can work with, primarily because if you look at things like construction, triangles are used often because they are structurally one of the strongest shapes when building things. Therefore, knowing how to find some measurements using the appropriate angles, very powerful skill. Today, this does have some direct application. It's more of a little niche area, kind of a specialized set of relationships that theoretically you could use the other tricks that we've done in the past to find these. But we're going to look at some special right triangles, 2 in fact, 2 very special right triangles, and talk about the relationship it has with its legs, its hypotenuse, and how we can theoretically calculate all those sides very quickly once we identify it as one of these 2 special right triangles. So the first one is a 45, 45, 90 degree special right triangle. So again, we know all the angles inside a triangle still have to add up to 180. But when you have a right triangle, 90 is already spoken for. And if you split the remaining 90 left over between the other 2 angles evenly, you get 2 45-degree angles. So a lot's going on here. In fact, in this first diagram, I'll look at this image here real quick. Straight off the bat, if 2 of the angles are the same, that tells me something special about their legs, and that's that they are the same as well. So this is special in a variety of ways. This is also could be called an isosceles triangle because it has 2 congruent sides. So lots of useful information there. But the relationship we're interested in is that the leg, we're going to use a variable to represent it because we're not always going to know what that leg measurement is. So I'm going to use X represents my leg. So in my diagram, I'll put a little X here on both legs since the 2 legs are congruent. There is a very unique relationship, though, for this special right triangle that says whatever the leg is, which is X, times the square root of 2 will always equal the length of your hypotenuse. So if you know your leg measurement, multiply that measurement by the square root of 2, you've got your hypotenuse. Now, there is that little reminder there off to the side. We've already put it in our diagram, and that's that the legs of a 45, 45, 90 triangle are always congruent, but we already sketched that in there. I guess the only other thing I would put in there, just to kind of tie it all together, is that the hypotenuse is right there. Now, this is a little bit challenging when you just look at it for face value. And I will say we're going to be shooting for exact measurements here. So hopefully your Algebra 2 skills aren't too rusty in simplifying expressions that have radicals in them. We're going to practice those today too. But let's just see what happens. So it's asking us to find the value of each missing variable. In this particular one here, how do I know that this is a 45, 45, 90 triangle?
Is the 90 value in there?
The 90's in there. That's important. So I know it's a right triangle.
And the 45 is too.
And there's a 45 right there, which means that only leaves me 45 for the other one as well. So straight off the bat, I know then that the 2 legs must be congruent, which kind of spoils half the work for us because then what does that automatically tell me X is? 8. Now, the hypotenuse, which is labeled as y in this one, is literally the measurement of the leg, which is 8, times the square root of 2. That's it. Now, that's an exact value. If I wanted to measure this out with a tape measure, I would grab a calculator and I would say, well, 8 times the square root of 2. And that's going to give me, just kind of as a side note here, 11.31 approximately. Now, we're going to try to stay clear from approximations today. We're going to try to stick with the exact values. So we're going to leave those radicals in our answer. Number 2, similar situation. Hopefully we see the right angle symbol. We also see the 45-degree angle in one of them, which means both are 45 degrees. So that tells me straight off the bat here that
Y is the leg.
the y is also the leg. We have, yep, one of the other legs is 25, so they would have to be congruent. And then just to kind of test you out here, what would x be? Sorry? Not quite. So x, we have a value for it. X is the hypotenuse. So maybe I should write it this way. The hypotenuse equals the leg times the square root of 2. Do I know the leg?
25.
25. Can I put a square root of 2 next to it?
Yes.
That would be your hypotenuse. Now, theoretically, why would, if I wanted to think about why would I need to know this? Well, if I was putting, again, my construction knowledge is very, very limited, but I assume somewhere in construction, you would have a 45, 45, 90 right triangle. If I knew the length from, say, a wall, if I'm putting in, I don't know, some sort of support, if I knew the length from the wall, that support was going to be anchored to the floor or to the ground, and I knew I was going to connect it at a 45-degree angle, I would just take whatever that measurement is on the ground times the square root of 2, and that would tell me how long of a piece of metal or wood I would need in order to fasten it at that exact position. So I wouldn't even, I would take the guesswork out. I would just multiply the leg by square root of 2. I've got the hypotenuse. That's how long of a board I would need. So it takes out some of the guesswork, for us in that situation. Number 3, this one's mean. This one's real mean because you'll notice it is another 45, 45, 90 triangle.
But it only gives the hypotenuse.
It only gives the hypotenuse. Good news is, once we figure out x, we'll also know y. The hard part is figuring out either of those. So what I'm going to do for this one, I'm going to write that relationship here real quick. Hypotenuse equals the leg times the square root of 2. Does it matter which leg I find?
No.
No. So I'm going to just put x in there for the leg. What's the hypotenuse?
19.
So 19 equals x, which I'm looking for, times the square root of 2. How can I get that x by itself?
Fine.
Where were you going to move?
I was just gonna say the square root of 2.
Yeah.
Get that from square. So square the other side.
So not quite. So that would, because the x is in the way. So it would cause a bit of a mess there. If the x was inside, that would have been perfect. But the x is outside, so it kind of ruins it. But I do want to divide by that square root of 2 because I want to break it away. Right now, x is being multiplied by the square root of 2. I do the opposite. I divide by the square root of 2. That gets rid of it here on the right-hand side. Now I'm going to do a quick flip around here. I get x equals 19 divided by the square root of 2. Now, here's the deal. Technically, that is a valid answer per se, but depending on who you're talking to in the math community, most people would tell you you never leave a square root in the denominator. So if you were to get to this point, I'm going to be 95% happy. If there's 5% of my brain that said I had to struggle to figure out how to adjust these, I want to at least show you how you would get that square root out of there. So the trick is we need to multiply it by essentially a fancy form of 1. Well, the fancy form of 1 would be square root of 2 over the square root of 2. Because when you have any number over itself, it equals 1, right? So what that becomes is 19 square roots of 2 over the square root of 4. And what is the square root of 4? 2. So x is 19 times the square root of 2 over 2. Now, if I was on the construction, crew, I probably wouldn't leave it as a radical. I would do a quick 19 times the square root of 2 divided by 2 to get an approximate value. But this would be the precise value for this particular measurement. Now, the good news is, do I have to go through that same process for y? No. We know x and y are the same. So y is also 19 times the square root of 2 over 2. So for the sake of the notes here, I'm gonna point out, let me see here. How am I gonna do this? I'm gonna say that this piece right here, this is gonna sound so technical. It's not, I'm joking, but this is what I like to call a fancy 1. Square root of 2 over square root of 2 is just 1, and multiplying by 1 doesn't change the value, but by using that fancy 1, it does change the way that it looks. Still the same value. If I were to grab a calculator and do 19 divided by the square root of 2, I get 13.44. If I do 19 times the square root of 2, oh gosh, times the square root of 2, and then divide it by 2, I'm going to get 13.44. It's the same exact value, it just looks different. I rounded. After the 3, I think it's a 5. So I just rounded up. Good job keeping me honest, though. So if you have one of the legs, that's the easier case on those. If you have the hypotenuse, it is going to be one of those little weird situations. But I think we can work through it. We're going to have plenty of practice today. So that is 45, 45, 90 right triangles. Both legs are congruent. The hypotenuse is just square root of 2 times your leg. The one that's a little bit trickier is a 30, 60, 90 triangle, which if you think about it, that still adds up to 180. The thing about a 30, 60, 90 special right triangle is that neither leg is the same because their opposite angles are different, so the sides are different. But in this particular relationship, the relations that we have here are all specific to the shorter leg. Now, quick question, we know which one's the hypotenuse, right? That's always the side right here across from the right angle. So would the leg here on the bottom or the leg here on the left be the shorter leg?
The one on the bottom.
Now, are you going because visually it looks shorter? Well, that's fair. And it should if this was made correctly. But there's a way to check ourselves. The shorter leg will always be opposite the smallest angle. So this angle over here is 30 degrees, right? When you follow it out, the side that it is opposite of will be shorter. The bigger the angle, the bigger that side becomes. So if you imagine this, if you look at the tips of my fingers, as I have a really skinny angle here, so my fingers aren't very far apart. As I increase that angle, the distance increases as well. So I forget which unit it was. I want to say it was the second one that we did with triangles. We talked about how there's a very direct relationship between the angle and the side opposite that angle. The bigger the angle, the longer that side, and vice versa. So our smallest angle in a 30, 60, 90 right triangle is going to be the 30 degrees. So the shortest leg is going to always be opposite that. And for this one in my diagram, I'm going to label that X. So my shorter leg in this particular diagram is X. To find the longer leg, you're going to take the shorter leg, which is X, and you're going to multiply it by the square root of 3. That one's going to cause a little bit of fuss, but we'll work that one out. The hypotenuse, that one's not too bad. You're going to take 2 times the shorter leg. So the good news is, if you know the shorter leg, you can drop it in for all the X's and you'll find all the other sides. The bad news is, if you don't know the shorter leg, that's going to be the piece you want to find first. Now, it does have a little note there. The shorter leg is always opposite the 30-degree angle, and the longer leg is always opposite the 60-degree angle. So visually, yes, one should look shorter than the other, but make sure, don't trust the diagram 100%. Trust the math. So we're going to try these out here. Number 4, how do I know this is a 30, 60, 90? I see the 90 and a 60, which means that must mean this one over here is the 30. So if that's the case, which one is my shorter side? The 5. Well, that's convenient because that's the one I'd really like to know. Because in order to find X, which is the, so that, let me maybe jot this in here. So 5 is the short, X is the long, Y is the hypotenuse. So if that's the case, to find the longer leg, I'm going to take the shorter leg times the square root of 3. So off to the side here, long equals the short times the square root of 3. And then to find the hypotenuse, we're going to take the short leg times 2 to get 10. So again, just as a reminder there, hypotenuse equals the short leg times 2. So everything's really with respect to that short leg. Continuing on, taking a look here at number 5. Similar situation. I know it's a 30, 60, 90 because I see the 90, I see a 30, which means this unlabeled one must be the 60. So I have one of the legs. Is that the longer leg or the shorter leg? That is the short leg. So I'm going to say short, just so I keep track of it, which means Y is the longer leg and X is my hypotenuse. So X is the hypotenuse. To find the hypotenuse, you do 2 times the shorter leg. 2 times 14 is 28. To find the longer leg, you take the short leg times the square root of 3, which is just 14 times square root of 3. Number 6, a little bit different here, but we can work through it. Again, I know it's another 30, 60, 90 because I see the 90, I see this 30, which means this one down here is 60. Which of the sides do I currently know? Careful. The hypotenuse. So the 32 is the hypotenuse of this one. And then when I look at the X and Y, which one's the short leg? X. Which means the long one is Y. Now, this one's a little bit different because if you think about it, we don't know the shorter leg, and that's what everything has been based off of. But what I can do off to the side here is I can remind myself that the hypotenuse equals the short leg times 2. Do I know the hypotenuse?
Yes.
Sure. 32. What's my short leg? I don't know, but I do have an X for it. So X times 2. How would I get that X by itself? Divide. So I'm going to flip this one around and say X equals, what is that, 16, I believe.
Yes.
So my short leg is 16. And now we're in business because if you know the short leg, you can figure out everything else. The long leg is just the short leg times the square root of 3. If I don't put this little guideline in there, it's going to drive me nuts. So I haven't written it down anywhere explicitly, but I probably should. If you don't know the short leg, find it first. That's for the 30, 60, 90. The 45, 45, that one's not too bad because if you know one leg, you know both legs. But for the 30, 60, 90, maybe, I'll tell you what, I'll squeeze it over here. Oh, wrong tool. Always find short leg first. Now, if you already know the short leg, do you have to worry too much about that then? No, you've already got what you really want to start with. So always find the short leg first if you don't already have it. I'm going to jump down here to number 7. Another 30, 60, 90. Looks like it gave us another hypotenuse here at the 46. I've got X and Y. Which one is my short leg?
Why?
The Y. Which means the X is my long leg. I want to find the short leg first. Divided by 2. Because if the hypotenuse is twice as long, then that means the short leg is, hypotenuse is twice as long as the short leg. Then the reverse of that is that the short leg is half as long as the hypotenuse. Half of 46 is 23. Make sure you put that on the Y, even though X really kind of is begging us to find it first. I need to know the short leg. Because now that I know that the short leg is 23 units, the long leg is just the short leg, 23, times the square root of 3. Number 8, another 30, 60, 90. Ooh, it's turning things upside down on us here a little bit. Which of the sides do I have?
long,
The long. Now, this is going to be the annoying one. If you start with the long leg, this one is going to require the most work, but we can get there. That must mean then that the Y is my short leg, and X is my hypotenuse. So I really want to find the short leg first. So what I'm going to do kind of over here in the margin is remind myself that, how am I going to write this here? Let's see. The long leg equals the short leg times the square root of 3. Do I know the long leg though?
40,
It's 20. What's my short leg?
y,
Y. And I have the square root of 3. How would I get that by itself?
divided,
Divide both sides by the square root of 3. And I'm going to do a little flipperoo here. That means Y equals 20 divided by the square root of 3. Now, again, that is an accurate value, but some math teachers in the world, sometimes me, depending on the day, don't like to leave radicals in the denominator. So what we do there is we actually multiply by another fancy 1. This time, though, instead of a square root of 2 over square root of 2, guess what I'm going to use?
3,
Square root of 3 over square root of 3. So I'm going to squeeze this in here. So square root of 3 times the square root of 3, which gives me 20 times the square root of 3 over the square root of 9. And what is the square root of 9? 3. So Y, I know it's kind of off-centered here. Y is 20 times the square root of 3 over 3. So that's my short leg. That just leaves me with X, which is my hypotenuse. How do you go from the short leg to the hypotenuse?
2 times the short,
Yep. So off in a different color down here. 2 times the short. I'm gonna squeeze it right up here. So 20 square root of 3 over 3 times 2 is the same as 2 over 1. Is the denominator going to change? It should not, but the numerator will. So 20 square roots of 3 times 2 gives me 40 square roots of 3 over 3. So not the prettiest thing to work out, but very precise, very, very precise. Last one on this page, similar situation, looks a little bit different, but let's not get too mixed up on that. Let's identify what we have, what we're looking for. Another 30, 60, 90, because I see that 30-degree angle and the 90-degree angle. I have this 9 square roots of 3. Which side of the triangle is that?
the long,
That is the long leg. Which means X then is my short leg. And Y is my hypotenuse. Okay. Remember, if you don't know the short, that's our goal. We have the long. So we remind ourselves that the long leg equals the short leg times the square root of 3. Something cool is going to happen here. My long leg is 9 square root of 3 equals my short leg, which I don't know yet. That's my x times the square root of 3. How would you get that x by itself? And it's going to happen both sides, isn't it? Yeah, so this one's pretty cool because on the right-hand side, square root of 3 divided by square root of 3 falls away. When I divide on the other side, square root of 3, because there's already a square root of 3 there, those are also gone. So I'm just left with x equals 9. That's a prettier number. I don't have to make any adjustments for. So what's the hypotenuse then?
9 times 2,
9 times 2
18.
gives me 18. So of the two triangles, the 30, 60, 90, a little bit more involved just because all three sides are different. 45, 45, 90, a little bit easier because if you know one leg, you know both. Then all you need to do is figure out the hypotenuse. But with a little bit of scratch work in there, we can work out all sorts of things. So we're going to throw it all together naturally. So some mixed review here. So I would warn you, when it says mixed review, that means there could be 45, 45, 90s or 30, 60, 90s. You need to get in the right frame of mind first before you dive right into it. Well,
yeah, with the first one is the 45, 45,
and you know that because
45.
you see the 45. So hopefully, if it's a good example, hopefully you should know one other angle besides the right angle, and that's going to give you a clue. If it's a 45, boom, you know what it is. If it's 30 or 60, then it's a 30, 60, 90. If it's anything else, well, it's not a special right triangle anymore. Everything we're practicing today goes out the window. But all of these should be special right triangles.
Even though it's two triangles, like two triangles, but they both have measurements, like would we still do that separate?
So you want to treat each triangle separately. And I'm going to do a couple of these here at the top, but we're going to jump down to 19 through 24 just because if you're going to struggle, it's going to be on those ones that are sharing sides. Okay, so on this one, because it's 45, 45, 90, the two legs are going to be the same. Unfortunately, I don't know either though. I just know the hypotenuse. So if I remind myself in a 45, 45, 90, the hypotenuse equals the leg times the square root of 2. I know the hypotenuse on this one is 28. The leg, doesn't matter which one we pick, they're going to be the same. I'm going to say x times the square root of 2. How would you get that x by itself?
Divided by the square root of 2.
Absolutely. Gets rid of it here off of the x. I'm going to actually flip mine around here. I get x equals 28 divided by the square root of 2. I'm going to use a fancy 1 here to get that radical out of the bottom. So I'm going to multiply by square root of 2 over square root of 2, which gives me 28 times the square root of 2 over the square root of 4. And what is the square root of 4? 2. So both of my legs should be the same, and they are 28 times the square root of 2 over 2.
Put that in my calculator, it rounds it to 14 cents.
Okay. Ooh, I'm glad you said that. Yeah, let's do that. Wait, pull this one up here. Cut this out. So your calculator is also kind of fancy, but if you think about it, the 28 could divide by 2, which is where she's getting the 14 square roots of 2. Now, if you're like, Josh, I didn't really notice that right away, but you got me this answer right here. I'm going to work with you on that. I'll be picky on some things, but on other things, I'm more interested in the process.
Instead of leaving it like that, I go back and do it myself.
Mhm.
It's gonna throw me a big loop, just 28.
Like how that gets to there,
Yeah, no.
Oh.
I like how it turns into that.
how it cleaned up on this one.
Yeah, that's simplified.
Now, that only worked though because that 28 was even.
Yeah.
On one of the earlier ones, we had one, it didn't divide nicely, so we just left it. Yeah, so that, there's no guarantee which way it turns out, but now we know that this is possible. So thank you for catching that, Shanice, because I totally blanked. Number 11. What type of triangle is this? The 30, 60, 90. So then we have to say, okay, that's the mindset we're in. So it looks like it gave us our hypotenuse. What's y? Short leg. And x then must be the long leg. Remember, on those 30, 60, 90s, we really want to find the short leg first anyways. And we're in luck. We have the hypotenuse, which is always 2 times the short leg. So how would I find out what the short leg was to begin with? Divide by 2. So y in this one is going to be 8. And then once you know the short leg, then the long leg is just the short leg times the square root of 3.
Where'd you get 8 from?
So that's a good question. So hypotenuse equals short leg times 2. So hypotenuse is 16. Short leg is y. Gosh, my equal sign's jumping on me. Divide both sides by 2. Oh. That's where we got y equals 8. Yeah, if you need to write that relationship somewhere, please do. Because then you just go into, hey, algebra mode. I know how to solve an equation. Yeah. All right. For the sake of time, I'm going to give you the rest of the answers for 12 through 18. I'm not going to linger very long on them, so we'll be a bit brisk. This is so if you want to go back and try these out, see if you're on track, you can. Number 12, x is 4. Y is 4 times the square root of 2. Number 13, x is 11 times the square root of 3. Y is 22. X is 15. Y is 30. Number 15, x is 9. Y is 9. Number 16, this one's going to be kind of sneaky because there is a simplification involved. If you try this one and you're stuck, come see me. But what you should end up with your answer fully simplified, x should be 4 times the square root of 3. Y should be 2 times the square root of 3. Number 17, x is the square root of 5. Y is the square root of 5. Number 18, x is 19. Y is 19 times the square root of 3. So again, there's all those answers there. If you're trying these exercises on your own before you try the assignment, you have a way to check, and then we can drive that conversation later. What I want to make sure we had time for is at least half of the problems down here, because you're going to notice a lot more going on. Each of them have 2 triangles, and if you look even closer, some of them, let's see here before I make a fool of myself, some of them have both a 45, 45, 90 and a 30, 60, 90. One of them actually has technically 3 30, 60, 90s, depending on how you're looking at it. So kind of slide there. So what I think I'm going to do, I think I'm going to do 20, 22, and 24. That's my goal. Just because of the variety there. So number 20, we got to be careful here because I have 2 special right triangles. I want to make sure I'm careful in how I label them. So in this one here, I see X. I'm going to label my 45, 45, 90 in blue. My X in that 45, 45, 90, is that a leg or a hypotenuse?
Hypotenuse.
That is the hypotenuse. And one of the cool things about 45, 45, 90s is that its 2 legs are congruent. Which means, although it's unlabeled, I know then that this side right here, this leg, is also 32. So while I'm here in this 45, 45, 90, let's go ahead and knock out the X. How do you find the hypotenuse in a 45, 45, 90? It's on the front.
And 45, 45, 90. X is square root of 2.
X square root of 2, X being the short or the leg. So leg times the square root of 2. So 32 times the square root of 2 gives me that hypotenuse. Now, that means we found all 3 sides in our 45, 45, 90. We now need to shift gears and say, okay, now I'm looking at the 30, 60, 90. And in that one, what side do I know? I know the hypotenuse. Yes, it was the leg earlier in the 45, 45, 90, but we already finished the 45, 45, 90. I'm not looking at that triangle anymore. So now this is my hypotenuse. So that makes Y, what's Y then? The long leg. And what's Z?
Short.
Must be the short. And of those 2 legs, which one do we usually want to find first?
Short.
The short leg. So if we need that reminder up here, hypotenuse equals the short leg times 2. For this particular one, our hypotenuse is 32. Our short leg is Z times 2. To find that short leg, all we need to do is divide by 2. So it looks like I get Z equals 16. Jot that down over here. My OCD is going to say, hey, Josh, move that over a little bit. So I do. Then all that's left is the long leg Well, the long leg is always the short leg times the square root of 3. So 16 times the square root of 3. That one's done. Can you guys see the color difference on the screen? There's a slight difference. It's not drastic, but I wrote sometimes blue and green. Yeah, so I did all the 30, 60, 90 work in green. The 45, 45, 90, I did that in blue. Of course, there's that crossover, that 32, which was a leg in one and a hypotenuse in the other, but we use it accordingly in each. Jumping down to number 22. This one's a sneaky one. It's kind of mean because there are technically 3 30, 60, 90 right triangles in there. So bear with me. I'm going to trace them here on the screen. We have the itty bitty one, 30, 60, 90. We have this medium size one, which is a 30, 60, 90. And if you take your moment and like kind of take a step back, this big one, in which encompasses the other two, is also a 30, 60, 90. So, well, good news is we only have to focus on one type of special right triangle, but depending on which one we're looking at, that's going to change whether it's a long leg, a short leg, or a hypotenuse. So I'm going to try to vary my colors accordingly, best I can. So I'm going to actually recommend we start with the smallest. And I'm going to do this one in blue. So on that smallest 30, 60, 90, which sides do I know? I know the short one. That's that ugly looking mess. X happens to land on its hypotenuse. And although it doesn't specifically ask for it, technically then that other leg would be my, what would that be, my long? Oh, how am I going to do this one? Because I'm going to actually evaluate that one as well. So hypotenuse, though, in that little tiny, little bitty thing there, hypotenuse in a 30, 60, 90 is just the short leg times 2. So 7 square root of 3 times 2 is going to give me 14 square root of 3. And then while I'm there, I'm going to go ahead and find that long leg. Although it doesn't specifically ask for it, it may prove useful later on. That long leg, let's see, is going to equal the short leg times the square root of 3. Now something rather unique happens here. The long leg, we don't know, so I'm going to leave it blank. Actually, I'll just say long. Equals the short leg, which is 7 times the square root of 3 times the square root of 3. Didn't give myself enough room here. So I get the long leg in there equals 7 times the square root of 9. What is the square root of 9? 3. What's 7 times 3? 21. So although it didn't ask for it specifically, squeezed in here. Actually, I'm going to put it on the other side because we may need it on this other 30, 60, 90. Don't mind me while I get extra. There we go. There's that one. Now, Here's the interesting part. Because we did the extra work to find that 21, if you look at the medium size 30, 60, 90, what did we inadvertently find?
Short.
The short. That's the one we usually like to begin with. So I'm changing to green now. I'm on the medium sized triangle. I now know the short leg. And then looking at the other ones, Z would then be the long leg, and Y would be the hypotenuse. Well, I'm in luck then, because if I know the short leg, it's just some quick calculations. The hypotenuse is always 2 times the short leg, so 2 times 21 is going to give me 42. And the long leg is always the short leg times the square root of 3. Well, the short leg was 21 times the square root of 3. I get 21 square roots of 3. And very conveniently, I now have my answer. Now, we didn't even touch the biggest 30, 60, 90, but if we wanted to do an extra exercise, we could actually dig in there and see that relationship, and you plug in all the pieces we just now found, everything still would work perfectly. But that's for another day, and for anyone who's thinking, man, I really like a challenge. Not necessarily today. So I'm going to jump down now to number 24. So being careful here, it's bringing back both of our special right triangles. So we want to make sure we're careful here. And I'm taking a look at it. I see the 45, 45, 90 on top. And what is alarming about that currently? Which side do I know? Oh, careful. Look at the 45, 45, 90. There's not a long leg or short leg. I'm looking at the one here on the top. I don't know either of them, do I?
No.
I don't know any of the sides. Now, I could say, just to save face here, I'll switch to green because I'm going to do the 45, 45, 90 in green. I know that X and Y are going to be the same because those are the legs of the 45, 45, 90. So that's good news. But then I look and say, I don't have enough information there. I don't have the hypotenuse. I need to then drop down to this one here on the bottom, this 30, 60, 90. And I need to work from there first. So in that one, which side do I know?
Long.
I know the long is the 18. Z is the short, which is what we usually look for first anyways. And then although it's not specifically labeled, that must mean this other side over here is our hypotenuse. Now, even though it's not labeled, will it serve a purpose later?
Yes.
Yes, because not only is it the hypotenuse of our 30, 60, 90, it is also the hypotenuse of our 45, 45, 90. So we'll come back to that here momentarily. But I need to figure out what I've got going on here. I see the short leg. I really want to know the short leg. I know the long leg. So I'm going to remind myself that the long leg equals the short leg times the square root of 3. Oh gosh, mild stroke. So the long leg we know is 18. Short leg is my Z times the square root of 3. I'm going to try to solve for that Z by first dividing both sides by the square root of 3. Now I'm going to do the quick flipperoo here. Z equals 18 divided by the square root of 3. Going to multiply this by my fancy 1, which is square root of 3 over square root of 3 to get 18. I'm running into my work here. 18 square root of 3 over the square root of 9. That's going to drive me crazy, so please hold live. fix it. Oh. Very crowded. What is the square root of 9? 3. So z equals 18 square root of 3 over 3. Now, I actually believe that simplifies further. Maybe we should do that as well. So 18 square root of 3 divided by 3 is where we're at. Does 18 divide by 3?
6.
Sure does. So z actually turns out to be 6 times the square root of 3. So that was convenient. What about the hypotenuse in the 30, 60, 90? How do you find the hypotenuse again? Isn't it like 2 times the shorter leg?
Yes.
Okay, so even though it's not labeled, I'm going to write in there 2 times the shorter leg. That's going to give me 12 square roots of 3. And that was important because now as we switch gears here to our 45, 45, 90, that 12 square roots of 3 is also behaving as a hypotenuse there. Pretty messy, isn't it? Well, let's see. Where am I going to squeeze this in? Hypotenuse, I'm going to do over here to the side. Hypotenuse equals the leg times the square root of 2. My hypotenuse is 12 square roots of 3 equals, we'll use x as our leg. So x times the square root of 2. Divide both sides by the square root of 2. Ooh, what a mess. I get x equals 12 square roots of 3 over the square root of 2. Ugh. Why would he be so mean? Why would he give this to us? Jeez. Getting that square root of 2 out of the bottom, I'm going to multiply by my fancy 1, which is square root of 2 over square root of 2, which is going to give me 12 square root of 3, excuse me, square root of 6 over the square root of 4 which equals 12 square roots of 6 over 2. And I do believe 12 divides nicely by 2. So I get, I know it's crowded, 6 times the square root of 6. We're in luck though, because now that I know x, I also know y. What a mess. Let's just shrink. I love technology. So here's the good news. If I give you one that's combined like this on the test, it won't be this busy. I'll make sure I pick out a nice one. I may not even pick one that's this complicated. I may just focus on 2 separate triangles. I don't know yet. I haven't made this section obviously yet on the test for tomorrow, but this one's dirty. This one's mean. It can be done, but it certainly couldn't be done easily with the amount of space that I provided. All right, for the sake of completion, we still got about 15 minutes left. We're not going to do the other 3, but I am going to give you the answers in case you want to try them yourself. So jumping back over here to number 19, there's the image for you. If you were to calculate this here, x would be 9 times the square root of 6 all over 2. Y would be the exact same thing. And Z would be 18. Number 21, if you wanted to try this one out, X, you should get 6. Y, you should get 6 times the square root of 3. And Z, you should get 6 times the square root of 6. And then number 23, X, you should get 10 times the square root of 3. Y, you should get 5 times the square root of 3. And Z, you should get 15. So those double ones do take a little bit of work. I would say the main takeaway there is make sure you focus and know which special right triangle you're working through first before you switch back and forth between the two. Try to knock one out before you do the other.